look at equivalent rational expressions and ways that you would simplify those. Starting with something like if you have a negative in front of the whole fraction, that's a negative fraction. So you could put that negative in the numerator, you could put it in the denominator, but just make sure you don't put it in both because that's a positive. 1/2 we want it to be negative. If you have a minus b over 3, other ways you can write that. Why we're going over this is sometimes you're doing multiple choice and you come out with this answer and it's not one of the choices, but maybe it's there. Remember, you can change the order as long as you take the sign with it. So this could be, nope, that could be negative b plus the a over 3. That might be a choice. Or you could put the 3 in the denominator, negative 3, which would make the a negative and the b positive. So that's the same answer as this one. When there's a negative out front of the whole fraction here, again, you can put that in the numerator, which would give you a negative a minus a b over 3, or you could put it in the denominator. But be careful, if you put it in the numerator, it applies to both the a and the b, not just negative a plus b. So here's one where it's out front. So we could put it in the numerator, and we'd have negative a minus b over a minus b. Or we could leave that a plus b and put the negative in the denominator. So it would be a negative a and a positive b, which you also would see written as a plus b over b minus a. Nothing you can cancel in that one. Now here that negative is right in front of this term, so it's not in front of the whole fraction. It's in front of the whole fraction. It's on an even level with this fraction bar. So other ways you could write this. I could put b minus a over a minus b. Again, I'm just changing the order, taking the sign with it. Or let's take that negative out. If I take a negative out of the numerator, it's a positive a and a negative b, but I have to do the same down here. It would be a positive b and a negative a. And that actually does cancel to negative 1. Because another way of writing this is a minus b. If I take a negative 1 out of this, I have a negative b and a positive a. So it cancels to negative 1. So anytime you see something like this, if you have x minus y over y minus x, that's negative 1. You can think of it in terms of if you had 3 minus 10 over 10 minus 3. 7 over negative 7 over 7 is equal to negative 1. So x minus y over y minus x is always negative 1. Let's see how else we could write this one. So again, the a is negative, the b is positive. So I could write b minus a over a minus 2. Don't touch those a's. Or I could deal with my negatives. Make the a, take a negative out of the numerator. So the a becomes positive, the b becomes negative. The 2 becomes positive, the a becomes negative. Same expression as this, just a negative taken out of each one. So down here, I could take a negative out and I'd have the b would be positive, the a would be negative. Have to take the negative out of here also, so the a would be negative and the b would be negative. You might see it written as negative a plus b over negative a minus b. No canceling. The one that cancels is this, x minus y over y minus x. Because that's like 3 minus 10 over 10 minus 3, which you know is equal to negative 1. And then just, this one's not dealing with the negatives, just in terms of canceling something like this. You can only cancel if you can go into all 3 of them. So all 3 can cancel by 2, so you'd have x minus 4. Never, ever, ever just cancel the 2's. And if you have something like this, this could be the result of quadratic formula. So take that 18, however you do that one, you can write 18 as the square root of 9 times square root of 2, which is 3 root 2. Or you can say the square root of 18, that's 3 times 6, which is 3 times 2. Anytime you have the same number twice, put it on the outside, and there's your 2. So this becomes 9 plus or minus 3 root 2 over 6. And now I have to find the number that goes into all 3 of these. It has to go into the 9, the 3, and the 6. You leave this alone. Even up here, you can't put 6 into 18. That's not 18. It's the square root of 18, which, you know, is 4 point something, so can't cancel. Can't cancel here either. But a number that goes into all 3 of these rational parts would be 3. So 3 into 9, 3 into 3, and 3 into 6. And you'd more likely see it as 3 plus or minus root 2 all over 2. And again, you can't cancel those. 2 reasons. One is that's not 2, that's the square root of 2. And also it has to be able to go into all 3 pieces. So when you're trying to simplify rational expressions, remember this idea of what to do with the negative, how you can take a negative out of the numerator as long as you take it out of the denominator, and then how to cancel over here. It really has to go into all 3 pieces. Okay, that's it.